Okay, so we're finishing up 4.8. And these are calculator active questions, so I would go ahead and jump straight to a calculator. And again, I know I've said it, but I've got to emphasize it, that pay close attention that this says the derivative of cosine of f. So cosine of natural log is equal to the derivative. Also, I guess I should mark this before I switch, is to make sure that you are in radian mode. I know I say it a lot, but it is just as important. It would be awful to miss a problem because you are in the wrong mode. Okay, so what I would do is, because it's just a habit of mine, is I just go straight to y equals cosine of natural log of x. And just look just right there. Now, as you start to do the problem, notice that the very first thing is they tell you that the interval is from 0 to 10. And so we can ignore everything else. Just look at from 0 to 10. So I would go to my window, go from 0 to 10. And then because of that, I only want to see from 0 to 10. I would hit zoom. And the 0 option is to fit it perfectly in my screen. So zoom 0. And now I have the graph of the derivative. And you might need to hit pause because your calculator might take longer than mine to do this. And I'm thinking about, okay, the derivative. So right here, that means with the derivative being negative that the function is decreasing. So if we're decreasing to increasing, we are decreasing to increasing. Okay, that's a relative min at that point. So do I want that? No, we want a maximum. So as you look at the other option, right here, above the x-axis is increasing, to below the x-axis is decreasing. This is the 0 I want. I don't know if you want to write that down, but something like that, that if we go from increasing to decreasing, and maybe I should clarify that the f prime of x is positive is why we're increasing to f prime of x being negative, and that's actually your reason. Let me write it right here, that f prime of x changes from positive to negative at, now let's use our calculator, let's be smart about this, that is a 0, wrong button. So second trace to calculate the 0, just move your cursor to the left, that's why it says left bound of that 0, hit enter. To the right of that 0, hit enter. And then your best approximation, and you get the answer rounded to 3 decimal places as 4.810. Oops, gave you the answer. I think I've said this to you recently. Make sure that you do not round twice. I've had students in the past, like, you only look at that next number. Like, do not round twice. Just, it's a 4, so it stays at 0. Can't emphasize that enough, I don't think. So what about that minimum? Well, we kind of already talked about that minimum. You know, this work right here is explaining this. And so that's my reason, that f prime of x changes from negative to positive. And notice that my reason is from the given information. I'm using the derivative to justify it. F prime at x equals, and then it's really the same button pushing. Second trace, we want the 0. You can hit 2 there. Just move your cursor all the way to the left of that 0. Oh, too far. Hit enter to the right, and then your best guess, about 0.208. So what about having a point of inflection? Well, a point of inflection that deals with the second derivative. And as a reminder, the second derivative is the derivative of the derivative. So what that means is that f prime of x, so we have a point of inflection means that the first derivative must either change from increasing to decreasing, which is what's happening in our picture, or decreasing to increasing, or in other words, f prime of x is a relative extrema. In this case, you could write it out that f prime of x changes from increasing to decreasing in this case, it's only at that relative extrema. Now you got to be careful though, because sometimes we also need to say decreasing to increasing. Well, I don't need to say only this time. I've actually had students in the past, and this is totally fine, is instead of identifying which one it is, they actually write f prime of x changes from increasing to decreasing or decreasing to increasing. And then they give the answer. But either one of these is fine, relative extrema. Because if you're changing increasing to decreasing or decreasing to increasing, that's your clue that the second derivative is changing. It's changing concavity is exactly what's happening. So your button pushing. Second trace, this time we want the maximum. You just need to be to the left of the zero somewhere, hit enter. Left of the max in this case. Hit enter to the right, and somewhere in between. And I would just give a value of x equals 1 here. Let's see what the answer key gives you. They went ahead and rounded it three different places, but I believe you'd be fine if you just said 1 at x equals 1. X equals 1. Might as well go ahead and give that 0.000. And notice that his answer key, which I have no problem sharing, even goes into how it matters that f prime of x is a relative max or min, is because the second derivative needs to change signs. So I like to use the phrase increasing to decreasing in this case. All right, and then the very last problem, I believe this is the last one. How many relative mins does the graph of g have for this? All right, let's go to the calculator. Sine of x over x plus 2. So I would just go to y equals sine of x over x plus 2. I also like to double check that I typed it in perfectly. And we still only care about from 0 to 10, but now my window has changed. Well, my window hasn't changed yet, but my graph has, so I have to go back and change my window, back. So my window is still 0 to 10. You might want to change that if it were a different problem. But now hit zoom 0 to fit in the screen. And what I care about in this problem is how many times that crosses, no, not just crossing the x-axis. We only care about mins. And if it helps, think about how a minimum needs to go from decreasing to increasing. You can even write that out, decreasing to increasing, which means for the derivative, so I'll write g, that means that the derivative needs to go from negative to positive. So as you look at the graphing calculator, all right, so it's positive, 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 to negative, so we don't care about that. And then negative to positive, so we do care about that one, and positive, we do not care about that one. So I counted 1. 1 relative min, and just to confirm that the answer key says the same thing, yeah, gave a quick explanation. And if my memory serves me correct, you should be ready for the homework now. So probably over-explained that first one. But anyway, good luck. Please reach out to me if you have questions, either email or Google Meets. I'm good either way.